Hey everybody, Mr. Qualls, and this is a lesson over 11.2, which is about the angle theorems for triangles. Now there's two of them. There's two angle theorems for triangles that we're going to talk about. One of them is the triangle sum theorem, which states that if you have a triangle and it has three angles inside all triangles. It's not named because it has three sides. It's named because it has three angles. And angle is just another word for corner, or it's ancient Greek, I think, for corner. And then 1, 2, 3, the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. Now, the reason that we want to keep track of that idea is this is going to be something that helps us solve problems this year as an algebra student and as a geometry student. So this is something that comes with you. It stays with you for a very long time as a tool to solve problems. The exterior angle theorem looks like this. It's a little more complicated, but what the exterior angle theorem says that if these are interior angles, then this thing out here, this is an exterior angle. So we need to keep track of between what is an interior or inside angle, an exterior or outside angle. And this is what we talk about when we have an outside angle. That if we extend this line out from the triangle, and we have 1 and 2 and 3, then this section out here is actually equal to the measure of angle 1 plus the measure of angle 2. Which, if you think about it, there should be 180 degrees on one side of a line. And those two plus the third angle equal 180, total to 180. That means that if we wanted 3 and this outside as 180, then the 1 and the 2 must also be equal to whatever is added to the 3 to make it 180. That was a mouthful, but that's basically what this is if we take these two angles and we put them both out here, they're going to equal this other side. We're going to use both of these ideas here to solve a couple of problems that we've got. Well, more than a couple. Okay? So, like I said before, one thing we need to do is keep track of what an interior angle is, or exterior, and then the triangle sum theorem, which a theorem is something that has been proven mathematically. Now we're not going to go over the proofs, but if you do watch the video that I put with this, if you watch the video that I put with this lesson about the pieces of triangles, and when I tore the triangle up and laid it down on one side of a line, you see that all three angles equal 180 every time. They sum to 180 every single time that we do that. And then I also have one for exterior angles as well, where I take those other two angles and I put them outside. Okay, so let's look at a couple of the problems that are in the book. So if you're working in your book on page 355, our first example is this up here, and it says triangle DEF. We have triangle DEF. And what we want to be able to do here is figure out what is angle E. What is the measure of angle E if we know that D is 100 and F is 55? The second example that they have on page 355 is this, JKL. And if we know these two, can we figure out angle K? Also, the third one, SRT. If we know these, can we solve that? Now, I'm going to pick this up for a second, and I'm going to show you what we're looking for here is our learning intention today is using informal arguments to establish facts about the angle sum and external angles of triangles. Okay, and then our success criteria is to set up the equations that describe these facts and solve these equations. So basically what we're doing here is we don't just need to know how these work, like the triangle sum theorem says that angles 1, 2, and 3 total to 180. And this, the opposite two angles in the triangle, or the remote interior angles, equal the exterior angle. What we want to be able to do is set up an equation and solve it. That's really where we're going here, is setting up an equation that works for these and solving this. So this is what I'm going to do. I'm going to take triangle DE and F, and I'm just going to mark here the measure of angle D plus the measure of angle E plus the measure of angle F must equal 180 degrees. Okay? Now, do I know the measure of angle D? Yes, it's 100. So I'm going to substitute 100 into my problem right here. So 100 plus, I don't know the measure of angle E. So I'm going to use that as a variable. I'm going to make a variable here. And I'm going to solve that. I'm going to solve for that variable in a minute, but I'm going to put X in for E. And then measure of angle F is 55. And then 180 over here. Excuse me. Now, how am I going to solve this? Well, I need to put my like terms together. And I have 100, I have a variable, I have a 55, and I have a 180. So I have a constant, a variable, and a constant. And what I need to do is put these constants together. So I'm going to use the commutative property of addition, which allows me to move pieces of addition around. So I'm going to do this, 100 plus 55. I'm going to move this over here, plus X equals 180. So I've used the commutative property, which means to move. Commute means to move. The commutative property of addition, brought that over. And now here it is. I can put the 100 and the 55 together. 155 plus X equals 180. And then I need my X to be by itself. And it's not, because there's a constant of 155 over here. So how am I going to remove the 155 from the left side? I'm going to subtract 155 from this side. I don't look over here to figure out how I'm going to solve this problem. I look over here. The X has 155 with it, and I need that to be a 0. 155, right? And whatever I do over here, I have to do over here. This is a 0. So that leaves nothing but X on the left side. It's X plus 0, but I never write down X plus 0 because we don't need to. We're more sophisticated than that. And then 180 minus 55. Well, let's borrow 5, and then there it is, 25. So it looks like X is 25 degrees. Let's check that, all right? What's 25 plus 55? 70, 80 plus 100 is 180, all right? So it's always important to go back and look. What was I looking for? I was looking for an acute angle. I found an acute angle. I'm probably right. Okay? So I solved. My goals were to use informal arguments to establish the facts. So I established the fact that these three together equal 180. And then I used the angle sum theorem, and I set up an equation. I substituted what I knew, and I created a variable for what I didn't. And then I used the properties of the commutative property of addition. I combined like terms. I used the additive identity property, because X plus 0 is going to be 0, and I used a 0 pair to make it. I did the same thing to the other side, and I got 25 to find my answer. Okay, so I set up an equation that described the facts of these, and then I solved for it. So that's how you can tell if you're doing something successfully here today, is if you can do that. So I'd like everybody just real quick to try this one. To try this, it's on page 355. Go ahead and pause the video. Try that, and then I'll be here when you're done. You might want to try this one as well if you're confident with that one. Try the second one. I'm about to do both. I'll wait. All right, and we're back. So what do I need over here? Well, I've got J, K, and L. So let's say measure of angle J plus the measure of angle K plus the measure of angle L equal 180 degrees. So I'm using the angle sum theorem to set up this equation. Now, what do I know? Well, I know the angle for J, so 71 degrees. I don't know the measure of angle K, so that's my X. Here's my X. Measure of angle L is 56, and it equals 180. Notice how when I do this, my equal signs are all lined up so that I keep track of what's on my left and the right side of my problems. In fact, I usually draw a line down that way. You should too. So we're going to move that 56 over here. We're going to use the commutative property of addition to move this. And there it is. Now, 56 plus 71 is 127 plus X equals 180. Now, what makes 127 into a 0? That's right, the opposite of 127. So I'm going to subtract 127 from each side. Notice I didn't pay attention to the 180 while I was doing the problem. I figured out what I had to do over here, and then that's what happens on the other side. I never work from the other side of the problem. Real mathematicians don't either, because, or excuse me, not real ones, but practiced ones don't. Not to say that you're not a real mathematician. But the ones that want to be better at this stuff don't pay attention to that number over there. They do the stuff over here, and then it just falls to itself over there. Now, 180 minus 127 is 53. So, was I expecting an acute angle? Yes, because these two totaled more than 90. So I was expecting something less than 90. And then 53 is what I got. So we're going to check that. So we're just going to put 53, 56, and 71. We're going to add those. 3 plus 6. Okay, that's 5, 10. Yep, 180. Very nice. Okay, that's how easy it is to check your work. To know I was looking for something that would have all three of them make 180 together to sum to 180, and then I got it. All right. Again, set up the problem. I set up the equations that describe the facts involved. I substituted for what I knew. I made a variable for what I didn't, and then I used the properties of mathematics or of algebra to solve my problem. Okay. And the last one. So I'm just going to go ahead and cut to the chase there and call that my X, since I don't know it, and I'm going to need a variable anyway. And then the measure of angle S plus the measure of angle. Why don't I just put this one over here to begin with now? Plus the measure of angle R equals 180. I'm going to draw my line down from there, and then measure of angle S is 29 degrees. The measure of angle T is 61, and the measure of angle R is X equals 180. Now, notice how I just kind of shifted that beforehand. It doesn't matter which order I put the three of them, list the three of them, because I was going to have to shift this over here anyways. I just took care of it now. 29 plus 61. If I put the 1 here, it's 30. Plus 60 is 90. Ooh, that's a special triangle. Now, what am I going to do? Well, I'm going to pay attention to this side, not that one. And what's going to make this X all by itself is making the 90 into a 0. And then 90. And I subtract 90 over there as well. X equals 90. Heights. Does that make sense? Well, 61 plus 29 is 90, and 90 plus 90 is 180. Sounds like we did it. Okay, again, I set up the facts with my equation. I substituted what I knew. I made a variable for the one that I didn't, and I set it equal to 180 because that's what the triangle sum theorem says. Then I combined my like terms, and then I made a 0 pair over here to get the X plus 0, and I solved the equation. So, Let's get rid of these. Woo! Oh, they must have been on the board for a while. They're not erasing very well. Now I'm going to draw a couple of them that have that deal with the exterior angle theorem. Now, exterior angle theorem does something like this. We have, these are going to be a little more complicated because, well, frankly, because they can be, is basically what we're going to do here. We're going to draw some things that are a little more complicated because we can make these a little more complicated. I know that doesn't sound right. We're going to make them a little more complicated because you're sophisticated students, and so we're just going to do what we can to increase your ability to solve this. Let me see what that looks like. All right, so I think that's good enough. So what we're looking at here is we're looking at 3y. This angle down here is 3y. And this angle here, and I'm on page 357. I'm on page 357 in your book. They're defining this one as 4y minus 4. 4y minus 4, and that's 3y. And what they want is, they want to, here's 52 degrees. And what they're asking for is they want us to solve for y so that we can solve the rest of this problem. We can solve the other angles that are here. So, the exterior angle theorem states that this angle out here is equal to the other two angles in the triangle that are remote angles. Now, remote means not next to. Okay? So this is the angle that is adjacent or next to the 50-degree angle. So these two here are the remote angles, the remote interior angles. So we want to know what this one and this one. So we're going to put this equal to, so 52 degrees equals the other two angles added together. 4y minus 4 plus 3y. Okay? So 52 equals 4y minus 4 plus 3y. 52 equals, if I put these things together, if I use the commutative property of addition and move the 3y up here, plus 3y minus 4, then I combine my like terms, 52 equals 7y, there's 4y here and 3y there, minus 4. Now, the next step of this equation is to get this is a two-step equation, and just because the variable is on the right side, who cares? We could rewrite this. We could rewrite this as this. Whoops. That doesn't make any sense. Let me grab my handy-dandy fancy eraser here. I'm going to rewrite this right here so you're a little more comfortable with it. 7y minus 4 equals 52. Many people don't like the variable to be on the other side, but that's okay. All I would have done was the same steps to solve it. So how am I going to solve this? Well, I need this to be a 0, and I need this to be a 1. So I'm going to add 4 to both sides. Well, that's going to be nice because 52 plus 4 is 56. And that's a multiple of 7. So here's my line down here. 4 minus negative 4 plus 4 is a 0, so I got rid of that. 7y. Now, I'm going to divide by 7 because 7 over 7 is 1. 1y equals 56 divided by 7. Yay, that's a fancy 7. Is 8. So y equals 8. So, what does that mean for us? Well, if y equals 8, that means that 3y equals 24. And 4y minus 4, 8 times 4 is 32. minus 4 is 28. Now, the way that we can check this is we can add 28 and 24 plus whatever is inside here. And we know that this is 180. So I took 180 minus 52. Well, 52. What is 28 plus 24? It's 52, right? But let's subtract this anyway. I'm going to borrow. That's an 8. This is a 128. So if I added 128 here, 8 plus 8 is 16, plus that is 20. That's an 8. There we go. Very good. So this angle in here is 128. Okay, we started that whole thing just knowing that this angle 52 was equal to these other two angles inside, the remote interior angles, and we solved everything else with a two-step equation. We set the equation up, knowing what, and used what we knew. We had a variable given to us, so we solved for the variable, and then we used the variable to solve the problem. All right, so the last thing we're going to do is on page 357, also on page 357. Again, I'm on page 357. And I've got a triangle that looks like this. And then we've got this long line going this direction. And it's 5y plus 3. This one in here is 5y plus 3. This one down here is 4y plus 8. 4y plus 8. And our exterior angle is 146 degrees. And what we want to do is solve for y and then figure out what these all three angles are. Okay? So go ahead and try it for yourself now. I'll be here when you get back. All right, first steps. What are we going to know? Well, what do we know? Well, we know from the the exterior angle theorem, that these two together equals this one. So that's what we're going to do. We're going to set those two up to equal that. And that is 5y plus 3 plus 4y plus 8 equals 146. Now, I can't do anything until my variables and my constants are together. And right now I have a variable, a constant, a variable, a constant over there. I want that one over there, but I don't want these over here. So I'm going to have to combine everything first. So let's move things around. So this is 5y plus 4y. I'm going to use the commutative property of addition again. Move that over there. Plus 3 plus 8 equals 146. So 4y plus 5y is 9y. So now I'm combining like terms and I'm rewriting it because I'm simplifying things. And once you simplify it, you want to get the other stuff out of your head. I'm not going to use a 5 or a 4 or a 3 or an 8 to solve this problem. I am, however, going to use a 9 and an 11 because this is 9y and this is 11. Now, I need a 0 and a 1. So I'm going to make my 0 pair. I'm going to subtract 11 from both sides. There we go. 146 minus 11 is 135. I don't know if I like this too much. Is 135 a multiple of 9? Let's see, 5 plus 3 is 8 plus 1 is 9. 135 is a multiple of 9. So we're going to bring this down. 9 what? So divide both sides by 9. You know, I don't know, rightly know off the top of my head. what that is. So I'm going to do 135 divided by 9. It goes in once, 945, 5. Okay, so 15. So y equals 15. What does that do for me? Well, that means that this y is 15. Well, 4 times 15 is 60, plus 8 is 68. So we're thinking this one's 68. 15 times 5 is 75, plus 3 is 78. Does that make sense? Well, 78 plus 68 is 4. Oh, sorry. 16, 7, 8, 146. Hey, it matches it, 146. Right there. So what is 146? What is 180 minus 146? 34. There we go right there, 34. All right, so I started off with just a bunch of variables, a bunch of stuff that doesn't look like we can solve anything from it, but we knew what the relationships were between the exterior angle and the two remote interior angles were. Set it up. We move things around so we can get things that are like each other next to each other using the commutative property of addition. Then we simplified things by combining like terms, and then we used our 0 pair and our 1 so that y was multiplied by 1 and added to nothing, which is the multiplicative property, multiplicative identity property, and the additive identity property, and solve for y, and then used y to solve for our angles. Okay, so rewatch this video as much as you need to. Shouldn't be too difficult. Thank you for watching.